This lesson we're going to discuss solving equations by factoring, and the difference between this lesson and the previous lessons is that we now have an equal sign incorporated into the problem. And the first thing that we need to do is make sure that the equation is set equal to 0 before we begin the factoring process. And of course all the other rules apply as far as descending order. When we're looking at this first equation right here, the first thing that should come to mind is that we need to eliminate these parentheses by using the distributive property. So we're going to say n times 2n is 2n squared. N times negative 3 is negative 3n. And while we're here, we have the equal sign. Let's move the positive 2 to the left and make it a negative 2. It's just the same thing as subtracting 2 from both sides, and therefore it'd be set equal to 0. It's in descending order. We cannot factor any other terms out. So because we have 3 terms, we're going to use the rooftop method. 2 times 2 is going to be 4. The factors of 4 are 1 times 4 and 2 times 2. Now, looking at this problem, we look at the second sign first, and we know we need to subtract to get the middle term of 3. So the only pair that subtracts to give me 3 is the 1 and the 4. If we want a negative 3, well, first of all, the second sign, since it's negative, means we're going to have opposite signs. If it's positive, then we would have the same signs. So in this case, we know we have opposite signs. One's positive and one's negative. Look at the middle term. If we want a negative 3, that means the 4 must be negative and the 1 must be positive. So we would take the positive 1 and the negative 4 out and put it over the first coefficient and the variable, because we'll look at simplified problems. In this case, the first fraction does not reduce, the second one does. 2 divides into 4 2 times. So our first factor, or a factor, is 2n plus 1 and n minus 2. At this point, we would set, to solve it, we would set each factor equal to 0. So the factor is everything that's within that parenthesis. So 2n plus 1 equals 0, and then we're going to set n minus 2 equal to 0. And in this case, we would move the 1 to the right hand side. We'd subtract 1 from both sides. That becomes negative 1. Divide both sides by 2. So our first solution would be n is equal to negative 1/2. Our second one is we're going to add 2 to both sides. So our second solution would be that n is equal to positive 2. In our next problem, we want to do the same thing, is that we want to set this equation equal to 0 first. So we're going to move the 16n to the left, because my highest degree term is the n cubed, and we always want our highest degree term to be positive. So that tells you what you need to move which way. So when I move the 16n to the left, that becomes negative 16n equals to 0. We can factor an n out to begin with, so that would leave us with n squared minus 16. We have 2 terms, and we have perfect squares, and we have a minus sign, so that means that we can go ahead and open our parentheses up, and we know that n times n is n squared. That minus sign says we're going to have opposite signs, and we know that 4 times 4 is positive 16, or the 16. In this case right here, we have 3 factors. We have this n as a factor, n equals 0. We have this factor, n plus 4 equal to 0. And we have this factor, n minus 4 equal to 0. So in the first case, we don't have to do anything else with this equation. That is our solution. Second case is we need to move the 4 to the right hand side, so we would subtract 4 from both sides. That makes it n equal to negative 4. And in the third case, we would add 4 to both sides, so we would have n equals to positive 4. And so we would have 3 solutions, which if you look at the original problem, the highest degree is 3, so most likely we will have 3 answers. We can have less than that, but we will not have any more than that. In this case right here, we have the highest degree is positive 3, so most likely we will have 3 answers. The very first thing I need to do is set this equal to 0. My highest degree is this 3, and it is negative, so I'm going to move it to the right hand side. So I'm going to have 0 equals to this negative 2 cubed becomes a positive 2 cubed. Then I would write my negative 30t squared, and I didn't change my sign because I'm on the same side of the equal sign. Then I would write positive 108t. And in this case right here, I would look and say, well, I can factor a 2t out. So when I do that, when I take 2t out, that's the greatest common factor for all 3 terms, that would leave me with t squared minus 15t plus 2 divides into 108 54 times. Now I have to look and see how can I factor this trinomial, and I would use the rooftop method. So I would have 1 times 54, which is 54. My factors of 54 are 1 times 54, 2 times 27, 3 times 18, and 6 times 9. Now this is a great problem because if you look at the factors, you have a pair that subtracts and you have a pair that adds to give you 15. But if you look at the problem, that second sign says add to get 15. So that means I have to use the 6 and the 9. That's the only pair that adds, and there will only be one pair that adds to give you 15. That second sign says your signs are the same. If it's a negative, automatically your opposite signs. If your signs are the same, then look at your first sign. If you want a negative 15, then these both have to be negatives. So you take your negative 6 and your negative 9 out, and you place that over 1t, because that's the part that you're factoring, not the 2t. It's just the 1t squared. So you're going to put it over 1t. Now, in this case, since it's 1t, that means you're not going to be able to reduce anything. So here are your factors, t minus 6 and t minus 9. And it doesn't matter which order you write these in. We have those set equal to 0, and do not forget the 2t. Because when you set your factors equal to 0, this is a factor. So you're going to have 2t equal to 0, you're going to have t minus 6 equal to 0, and you'll have t minus 9 equal to 0. So in the first case, to solve this for t, we would divide both sides by 2. So we would have t equals to 0, because that is what 0 divided by 2 is. Second case, add the 6 to both sides. We would have t equals to positive 6. Third case, add the 9 to both sides. So n equals to t equals to positive 9. There's our 3 solutions. Sometimes there are very simple problems wrapped up in the homework problems, and this is one case scenario that's an example of that. If you look at this problem, first of all, it's already set equal to 0. Second of all, it's already factored. It's very tempting to FOIL this out, but what you would end up doing is factoring it back out to these original factors. So I just wanted to save you some time here. Now, if this were not set equal to 0, say if it was equal to positive 2, you would have to FOIL it, move the 2 over, set it equal to 0, factor it out, and then solve it. But in this case right here, I can go ahead and say my first factor is set equal to 0, my second factor is equal to 0. So in this case right here, subtract 4 from both sides, so x equals to negative 4. This case, add the 1 to both sides, becomes positive 1 right there, divide both sides by 5, and you have x equals to positive 1/5.